One of the most dramatic battles in the universe takes place inside a star nearing the end of its life. In this battle, two giant forces face each other: gravity and quantum mechanics. When a star exhausts its fuel, it can no longer produce outward energy and begins to collapse inward under the pressure of its own gravity. However, an extraordinary force intervenes at the heart of the star to resist this collapse: the Pauli exclusion principle. Coming from quantum mechanics, this principle forbids two fermions, such as electrons or neutrons, from occupying the same quantum state. This prohibition creates a quantum pressure in the star's core that opposes gravity. Thanks to this principle, the remnant of the star can survive as a white dwarf. But even this resistance has its limit. This limit was first calculated by a 20-year-old Indian physicist, Subrahmanyan Chandrasekhar. According to him, if the mass of the collapsing core exceeds 1.4 times the mass of the Sun, the pressure created by electrons can no longer withstand gravity. Today, we call this critical value the Chandrasekhar limit. If this limit is exceeded, the star collapses further and transforms into a neutron star. Neutrons then step in and try to stop the collapse with their own exclusion principle. But if gravity is even stronger, if the mass exceeds about 2 to 3 times the mass of the Sun, no force, no quantum law can stop this collapse anymore. The star collapses into itself and becomes a point of infinite density, known as a black hole. Light itself can no longer escape from this dark region. Everything a star does throughout its life is a preparation for this final test. And sometimes, the most mysterious structure in the universe, a black hole, is born from the last breath of a star.